And now for a quick review of the basics of pre-calculus and trigonometry. First, functions. A function acts like a little machine that takes exactly one x and converts it into exactly one y, or f of x. So if the function is f of x is equal to x squared, an x of 2 would become 4, 3 to 9, etc. An easy way to tell if an expression is a function is to graph it and use the vertical line test. If a vertical line only ever passes through the graph at one point, then it is indeed a function. You can mess with functions to find their symmetry. If you find that f of negative x is the same as f of x, that function is said to be even, meaning it is symmetrical with respect to the y-axis. If instead f of negative x equals negative f of x, the function is considered odd and has symmetry with respect to the origin. There are some basic function shapes, but you can shift them around, stretch them, squeeze them, whatever you want. For example, by adding 3 to x squared, I can shift the entire graph up by 3. Or if I square the quantity x plus 5 instead of just x, I can move it to the left by 5. Side note, if you ever need to graph a weird-looking function like this one, you can complete the square to simplify it. In this case, you'd take this middle number, divide it by 2 times this first number, and square the result to get 9. Then you add and subtract it to balance it all out, and it neatly simplifies down to something easier to graph. Back to stretching and shrinking. Doubling the value of a function effectively doubles the height of a function within the same horizontal space. Doubling elsewhere within the function, however, keeps the height the same while squishing twice as much graph into the same space. And finally, with a nifty little negative sign, you can reflect any function, or flip it upside down. While we're on the subject, it might be a good idea to brush up on some trigonometric identities. There's the famed SOHCAHTOA to help you find sine, cosine, and tangent. It's also good to know that the inverse of sine is cosecant, the inverse of cosine is secant, and the inverse of tangent is cotangent. Plus, with the help of the Pythagorean theorem, we know that sine squared plus cosine squared equals 1, that 1 plus tangent squared equals secant squared, and 1 plus cotangent squared equals cosecant squared. The sine of 2x is 2 times sine and cosine, the cosine of 2x is 1 minus 2 times sine squared, and the tangent of 2x is 2 times tangent over the quantity 1 minus tangent squared. The inverse of a function is like a machine that does the same thing but in reverse. They cancel each other out. To find a function's inverse, you write out the function equal to y, then you solve for x in terms of y, then at the end you switch the x's and y's. The resulting graphs of f and its inverse will look like the same graph reflected around the line of y equals x. Exponential functions include some number raised to the power of x. Since any number to the power of 0 is 1, their graphs always pass through the point 0, 1. The inverse of an exponential function is a logarithmic function, which looks like this, and passes through the point 1, 0. One last point. Not every function has an inverse, only the ones with one x for every y, because if you flip them otherwise, they end up with multiple y's for every x and aren't functions. The horizontal line test can be used to determine this.